Hello everyone, welcome to this problem on day 9 of September. So the problem here is spiral matrix 4. So in this problem we receive as input m and n which denote the number of row of a given matrix and the number of column of the matrix. And then now we are supposed to fill element in that matrix with element of a linked list following the clockwise move. What does that mean? That means, let's say I receive as input a 3 by 5. That means I'm going to have a matrix with 3 rows and 5 columns. And let's say I receive this as my linked list. That means I'm going to fill like this. I'm going to have 3, 0, 2, 6, 8, and so on. So we are aware of what we are supposed to do. So now for me, the key things here is to be able to move properly, like being able to know what is the next move. What does that mean? That means when I'll be here, I should be able to know exactly where I will go after this. So that for me, that's the first thing I should be able to do. And the second thing is being able to loop through my linked list. And that is something that you should already be familiar with all of the things that we have done since the beginning. If you haven't watched, check the previous video. The 3 or 4 previous video are linked list related, so you will definitely be comfortable with linked list after seeing those videos. So now what will be our approach of solving this problem? So to solve this problem, what we are going to do is that we are going to define a move flow. So for me, I have 4 options. Either I go straight like this is actually adding element, this is actually adding 0 to the row and adding 1 to the column. So that means if I want to move forward, I'm going to have 0 to the row and 1 to the column. And if I want to move now down like this, I'm going to have now 1 to the row and 0 to the column. And now the third one, if I want to move like this, just the opposite of this, so it's just like 0 minus 1. And the last one, if I want to move upward, it will be now the opposite of this one, which is minus 1 0. So for me, these are the possible move that these are the possible move that I can do. So what my idea will be as follow. I'll just initially I'm moving this way, so I'll just have something like a direction. I'll call it D, that is going to take 0, telling me that I'm moving this way. And once I will have the value say telling me that I'm moving this way, when I will not be able to move this way anymore, I'm going to move downward. When I will not be able to move down, I'm going to move like this, and after like this. And when I will be moving up, this is actually the last one, the third option. To move now up, I'm going to have just the last option plus 1 modulo 4. So I'm going to come back at 0, which is this way. So it's actually almost similar to the robot move that we did previously. So for this, I'm just going to have now a vector of int, a vector of int, and I'm going to call it direction, which is going to be like this. So now I have my direction, and then this is my initial, like I would say, orientation. And I will have something like, I prefer to call it like this, position X and position Y. So with those two things, I know how I'm moving and I know my initial position. Once I have those two elements, I can now loop. So my loop will be as follow. While I have head, I'm moving in here. I will need one thing, which is my matrix that I will return. So it's a vector of int that I'm going to come result with a size m, which all of the elements are vector of int of size n. It's important to give them -1. Why? Because I'm going to show you why. Because for me, when I'll be here, I'll have two options, either move up like this or like this. The only thing that will tell me to not move like this is that I will see that, okay, this is a value different from -1, so it has been visited before. So when I will find something like, I will know, okay, this is not a valid move, I will now move like this. So I'm starting everything with -1 because I know value are actually element from 1 till 10 power 5, right? So by doing so, I'm 100% sure that valid move are actually move within the grid with value equal to -1. So those are actually valid move. Is that clear for you? Okay, if it's clear, let us continue. So while there's head, what we are going to do is that we are going to say the matrix of px of py, we take head dot val, and what we have this now, we are going to move, and the move will just be like, okay, I'll say I'll have integral variable. I will say possible move x will now be equal to px plus direction of d of 0. Make sense? Of y will now be equal to py plus direction of d dot 1. So this is actually the possible move if everything is okay. And what makes this possible move valid is valid if it's within the grid. Within the grid, if pm of x is actually greater than 0, greater or equal to 0, I would say greater or equal to 0, and the pm of x is actually tied to rho, so it should be less than the number of rows is m, less than m, and then now pm of y is actually greater or equal to 0, and pm of y is actually less than n, and matrix of pmx of pmu is actually equal to -1. This is what I call a valid move. You are valid if you are within the grid and if the value is actually -1. If it's the case, then we're just gonna say px is going to take pmx, and we're gonna say pu is going to take pmu. By doing so, if it's valid, you are moving, you are validating that, okay, that is the move. Otherwise, what will happen is that you are not going to move toward the direction you are moving, but you are going to change the direction. And like we said, changing the direction is actually d is taking d plus 1 modulo 4, and by doing so, now you can update the position of px is actually equal to, is actually this, and pu is actually equal to pu plus direction of 1. And at the end of this while loop, what you need to do, you need to return, how did I call it, the result. So is this clear for you? If this is clear for you, let us try and submit and see what it gives. This will not work because you are going to fall into infinity. Why do I have compilation error here? Why? Matrix are not be defined. Who is matrix? So matrix doesn't exist. I have matrix here instead of result. I'm mixing things, so I'll just call this matrix, and I'll call it matrix. And then whenever I'm moving, after each operation, I'm going to say head is now going to take head dot next. Let us run again. We have everything green. Let us submit. Perfect, it's working. So this was my approach of solving this. I hope you do enjoy it. Feel free to give me any input. I'll be really happy to interact with you regarding this. Don't forget to like, share, and subscribe. See you tomorrow for a new video. Ciao.